wonderful platform that is BYJU'S Exam Prep. And guys, today we are here in the second session of the welding. In the first session, we have seen the principle of welding. And in this session, we will see the types of welding, and also we are going to solve some problems which are related to the concept of welding, transformer and all, what we have discussed in the yesterday's class. So guys, just like and share the session so that other student can also join it. It is very important guys, because today we are going to learn the problem practice, which is going to give you a 2-mark numerical for sure. Okay, so today we will see numericals, that how numericals can be asked in the arc welding. Okay, so that we are going to see. Okay, so it is very important session as well as interesting as well. Okay, so let us move further guys. So guys, those who are watching me for the first time, this is some introduction about me. My name is Dheeraj Sir and I am going to take production in this session, and my experience is around 10+ years. I have done my masters from NIT Bhopal, and these are my areas of expertise, and I have written many research and review paper also. Okay, so let us move further guys, and please tell me, am I properly audible and visible to all of you and not? Guys, this is an announcement related to the session on this Sunday at 12. Okay, at 12 noon. So we are going to have this session where we will discuss all the previous year's questions of strength of material, engineering mechanics of civil and mechanical branch of these years when IIT Kanpur have conducted the exam. So you will get to know which type of question have been asked, and you will get the authenticated solution along with the wonderful concept. We have already seen 25 question of one branch on previous Sunday. You can see the session is available, and on this Sunday we will see the rest questions. Okay, Midun, good evening dear, how are you? So guys, this is one more announcement why we are having the session at 12, because on 11 you are going to have a scholarship test where you can get up to 90% scholarship for GATE preparation courses at BYJU'S Exam Prep. So register now for that. 11 AM will be the timing of the test, and here you can register it for free only. So guys, yesterday we have seen about VI characteristics, and related to that, this is question number 1 for us. So my dear, if you remember, we have derived an equation, V is equals to V naught minus V naught by IS into I, and this equation is also known as VI characteristic. Madhu Vamshi, hi dear, good evening. So this equation we have already derived yesterday. Okay, so before we solve, I would like to give you an idea that which type of questions are about to come. Shubham, good evening dear. So you already know that power is going to be voltage into current. Okay, so when you know power is voltage into current, the value of voltage is there in this equation. You know V naught is open circuit voltage, it is a constant. IS is short circuit current, it is a constant. V naught is a constant. So my dear, only variable is I. So when you will be putting this value in this equation, you will be getting power to be equals to voltage is V naught minus V naught by IS into I, and you will be multiplying it with I. So what you are going to get, you will be getting power as V naught I minus V naught by IS into I square. My dear, they will be giving you a question, they will be asking you for maximum power. Shreya, good evening dear. Bhanu Teja, good evening dear. So when they will be saying to maximize the power, you know, here only one variable is there, that is current. So you will put dP by di. dP by di is equals to 0. And when you will be putting dP by di to be equals to 0, then my dear, you will be getting dP by di, V naught is a constant. Okay, then minus, you know, V naught by IS is a constant, and here you are going to get as into 2I, into 2I. So my dear, you can see whenever you are going to solve it, putting it to be equals to 0, V naught will get cancel out. You will be getting I to be equals to IS by 2. And when you will be putting this value, you can see this, what you are going to get. So V naught will get cancel out, and you will get this. And when you will be putting this value in this equation, you will be getting V also V naught by 2. And you are getting V as V naught by 2, I as IS by 2 based on one condition where you are going to maximize the power because you have kept dP by di to be equals to 0. So these are the condition for maximizing or optimizing the power. So this is the general concept I have discussed. Now we will be coming back onto the problem. Manas, good evening dear. So I feel some of you have already given the answer like Shubham and Madhuvamshi. So dear, before giving the answer, okay, fine, good. So those who have not solved, for them I am telling you the voltage arc length characteristic of a DC arc voltage is given as V is equals to 20 plus 4L. So I would be writing that V is equals to 20 plus 40L. This is given, and it is mentioned that arc length is in centimeters. So I feel Madhuvamshi and Midun have not seen that length is given in centimeter and they have asked the answer in mm. That's why they have answered it wrongly. Shubham and Madhuvamshi. Yes, Midun have given it correct only. So my dear, they are saying power source characteristic can be approximated by a straight line. When they are saying they are approximated at straight line, I already told you straight line means this, where this is open circuit voltage, this is short circuit current. This is the curve between V and I. So you will be writing the equation whatever we have seen. V is equals to V naught minus V naught. V is equals to V naught minus V naught by IS into I. This we have derived yesterday. So the same equation we are going to use. I feel majority of you have given the answer. So guys, if you see this, they are saying that open circuit voltage is 80 volt, short circuit current is 1000 amperes. So my dear, open circuit voltage is 80 volt, open circuit voltage is 80 volt, short circuit current is 800 ampere. Let me cross check again. They are giving us 1000 ampere. Very good. So they are giving 1000 amperes. Okay guys. So what they are asking V is given to us. You need to find out the arc length for optimum power or optimum arc length. So my dear, if you want to find out that, for that what we need to do? Obviously, when we are talking about optimum voltage, optimum current, optimum power, optimum arc length, Nagaraju, good evening dear. So when we are talking about optimum, we need to optimize the power. So my dear, you will do the same thing what I have done in the previous slide. You will see dP by di to be equals to 0. But for that you need to make the equation in current only. And the same procedure I have done. V was this, P was V into I. I kept the value of V. The equation came in terms of I, and I was having the equation P is V naught I minus V naught by IS into I square, and from that what I get, power will be optimum when I is IS by 2. Power will be optimum when V is V naught by 2. The same thing you will be doing. So my dear, when you will be doing this, I am repeating this for you, otherwise there is no requirement. You know P is V into I. So you will be writing P is equals to V naught is 80 minus 80 by 1000 into I and into I. This is power. So my dear, when you will be differentiating it, dP by di to be equals to 0. When you will be doing this, what you will be getting? 80 into I will be having differentiation 80. Then 80 into I square by 1000 will be minus 2 times 80 into 1000 into I is equals to 0. You will get I to be is equals to 500 ampere, which is nothing but IS by 2. Putting this value in this equation, you will get V to be 40 volt, which is nothing but V naught by 2. And putting 40 volt equals to 20 plus 40L, you will be getting L to be equals to 0.5, but this is 0.5 centimeter. But my dear, they were asking you answer in mm. So my dear, our answer is going to be 5 mm. So that was the twist in this problem. So I feel you got how to solve this type of question. Generally people are following this, but I will say when we already know that answer is going to be V naught by 2 and IS by 2, then why we are going for this complete procedure again and again? Because this type of many questions have been asked in previous years GATE paper. So when this type of many questions are there, why we need to go for this procedure every time? Why not we are directly writing V is V naught by 2, I is IS by 2. That would be better. Okay guys, so that's why you will be getting the answer to be 5 mm. If they would be asking in centimeters, then A is going to be correct. Okay, so Madhuvamshi, Shubham, Teju, Sagnik, yes, hello to all of you, and very good guys, those who have done it. So Shreya, are you getting it or not? So let us move to the next problem guys. This was the first question we have solved. So my dear, this is the second question, and when we are talking about the second question, a direct current welding machine. A direct current welding machine with a linear, when they say linear power source characteristic, they mean with that only, VI, and they mean this equation is to be valid, V naught minus V naught by IS into I. Yesterday we have seen this equation in a great detail. This equation we have seen how it is coming. Then my dear, they are giving open circuit voltage to be 80 volt. Short circuit current to be 800 amperes. So when they are giving this, it means they are asking during welding with the machine, the measured arc current is 500 ampere corresponding to the arc length of 5 mm. And they are saying the measured arc current is 460 ampere for a arc length of 7 mm. So my dear, actually in GATE examination, generally numericals are coming only. From welding, whatever you have studied in your college, that is majorly theory. So generally students are not aware of these things, that yes, welding can have some numerical. So my dear, for that I am giving you each and everything very clearly. I already told you, when you are having arc welding process, then between electrode and workpiece there is some gap, and that gap is having some air. If air will be more, resistance will be more. If air will be less, resistance will be less. So I told you, when we make voltage arc length characteristic, then it is coming like this. So he is saying that what are voltage arc length characteristic? They are denoting voltage by E and arc length by L. So let us assume this voltage V, they are saying it E, so you can write it E also, is equals to, let us assume A plus BL. Now you need to find out the value of A and B, because that equation is asked from you. Some students have given the answer. Divyansh Kohli, good evening dear, how are you? So dear, when you are going to solve this question, how to solve it? So we know that this is A plus BL. So we can write A plus BL. Open circuit voltage is 80 volt minus 80 volt by 800 amperes into I. So my dear, this is the equation. We want to find out A and B. For finding out two unknowns, we need two equations. Okay, there are two unknowns, A and B, so for that we need two equations. So I am removing this. This is 80 volt. So my dear, when we are going to solve it, you can see there are datas given with the help of which we can solve it. They are saying that for 500 ampere it is 5 mm. So you can put the value A plus 5B is equals to 80 minus 80 by 800 is 0.1 into 500. And you can make the second equation also. For 7 mm it is 460. So you can write A plus 7B is equals to 80 minus 0.1 into 460. So my dear, this is equation 1. This is equation 2. You need to solve 1 and 2 and find out the value of A and B. What I want to say that these are the types of problem. You have seen the first question, that is one type of problem. This is the second type of problem, and all these types of problems are very important because they are directly being asked in the GATE examination. So when we are talking about this, there are two equations. You will be solving them. They are A plus 5B is equals to, A plus 5B is 80 minus, it is 0.1 times 500. Then A plus 7B is equals to 80 minus 0.1 times of 460. So when you will be solving this, A will be coming out to be 20, B will be coming out to be 2. Equation will become 20 plus 2L. So this type of questions are coming in GATE. So I am covering each and every type. Ambati, you can try the conventional previous year's conventional papers if you are living in such remote area where you cannot get that advantage. Then my dear, actually it is required because practice is required. Otherwise you can try the previous year's papers by sitting for 3 hours and just see how much question you are able to attempt. So you can do in that way if that is the issue coming. Otherwise try to come out for some days in some other area of your relative where the facility is available. I will recommend you that, because for anything test is required. Okay, but that's wonderful, you have qualified objective. So my dear, these are the 2 questions we have solved. There are 3-4 other types which we are going to discuss after some theory discussion. So my dear, now we are coming to the second type of arc welding process, that is said to be submerged arc welding process. When we are talking about submerged arc welding process, my dear, this is again a type of arc welding process. I already told you when we are going to discuss, good evening Achintya, when we are going to discuss that there is some second type of welding process, we must have some points in our mind that why the first type of welding was having some issue. Because of that only we are going to the second type, because the first type of the welding was enough to do welding for everything, then why we will be going for some other types. So my dear, we went for the second type, that is submerged arc welding. In short, it is said to be SAW. So we went to this type of welding because there were some problems with the manual metal arc welding process. So my dear, the very first problem with manual metal arc welding process, there you were using an electrode. And my dear, that electrodes are having generally the size of 9 inches to 12 inches. So that is the size of an electrode. You know that electrode was melted out and the molten mixture was going into the groove. So electrode will be melting out, and once one electrode will be melted out, you will use the second electrode. Second electrode will be melted out, you will be using the third electrode. It means all the times when electrode will be melted out, you will be changing the electrode. For changing electrode, you need to stop the welding process for some time. And if you need to stop the welding process for some time, it is not going to be a continuous welding process. So if you are going with not a continuous process, my dear, then every time you will be restarting the welding, there will be a joint. And my dear, at joints there are high chances of leakage. So my dear, if you are making some applications like LPG cylinder, let us say you are going to weld some LPG cylinder. I am going to show you an example for that. For that I am taking a page. Okay guys, so just look at it. Let us say this is the sheet of cylinder and you are going to weld the cylinder like this. So when you will be welding the cylinder like this, you know that this is going to be made up of some thick plate. So when you will be welding it, after welding for some distance, electrode is over, then some distance electrode is over, then some distance electrode is over, then some distance electrode is over. So there will be many joints present, and at all the joints there will be chances of leakage of the gas, LPG gas. And everybody knows if LPG gas is going to leak, what blunders can happen. My dear, what kind of accident we can expect. So my dear, we never want such accident to happen. That's why for the application like LPG cylinder, we want some continuous type of welding process, which manual metal arc welding was not. Okay, so manual metal arc welding was not at all a continuous process. That was the first problem. Now we are moving to the second problem, my dear. The similar problem, if we talk about like LPG cylinder, there is a ship building process. You know, ships are very big in size. So they are not made like in some company you went and you are going to purchase something that give me a ship and you will be taking that. It is not like that. Like we are going to manufacture the house or manufacture the house by going at that location where house should be made. It is not like you went to some place and you said, I want 2 houses, please give me. They will not going to give you. There should be some place where house are going to be made. In similar way, ship productions are also happening. So when we are going for ship building processes, so in ship also they are using very, very thick plates. So my dear, let us say you are joining, let us say one plate is this and we are having one more plate. I am taking one more page, guys. So let us say you are making a ship which is made up of these 2 plates like this. You know the shape of ship. So when you will be making these 2, you will be joining them like this. If these are 2 sheets, you will be joining them sideways like this. So when you will be welding like this, then my dear, if there is a kind of leakage or joint in between, you know what kind of accident can happen, because water will come inside and it will definitely be giving rise to an accident which we never want to happen. So my dear, the applications like shipbuilding, the applications like pressure vessels, LPG cylinder, where there are chances of leakage, my dear, we want continuous welding, which shielded metal arc welding was not. So my dear, because of that, we wanted some advanced process which is going to be of continuous type. Second problem, my dear, second problem. My dear, when we were having shielded metal arc welding process, it was manual metal arc welding process. There was a problem of slag inclusion. Slag inclusion was coming because of some reasons. What were the reasons for that slag inclusion? You know that. For slag inclusion, the problem was the motion of electrode towards workpiece was in such a way that the gap between them was always variable. So these 2 issues were there with the manual metal arc welding. And my dear, for resolving those 2 issues, we are going to have the second process in welding. The name of that second process is submerged arc welding process. So here, to make the welding process continuous, we wanted a continuous electrode. So previously we were having a electrode of 9 inches to 12 inches. We have replaced it by taking an electrode wire. So I am making a parallel diagram. So we have made an electrode wire. So my dear, we have put it that electrode wire on a wire spool. Wire spool is the same charkhi which you are using at the time of Tej when you are going to fly the kites. So when you are going to fly the kites at the time of Tej, you are using that charkhi, that wire spool. The same kind of wire spool is present. So we are calling this as wire spool. So my dear, to provide the continuous welding, we are removing the electrodes and we are providing an electrode wire. Now my dear, this wire is going to be there, going to be wound over the wire spool. So if flux would be present on the wire, when this will be coming, because of relative motion on the wire spool, the flux is going to come out from the electrode, which we never want. We never want electrode to come out, so flux to come out. That's why my dear, when we are using submerged arc welding process, we are not using the wire with flux. We are using nude wire, and on this wire there is no flux coating available. We are not using any kind of flux coating in submerged arc welding process. Everybody remember what kind of functions flux was doing for us? What kind of things flux were doing for us? Flux was performing 3 very, very important functions for us. It was saving our molten weld pool from atmospheric gases. It was providing direction to the flame or spark. It was providing the alloy content for the weld bead. Do you remember or not, guys? So those 3 important things were done by the flux. So here we are not using flux with the electrode wire. So where the flux will be there? Because flux functions are very, very important. So my dear, in this case, we are using the flux in molten format. So there is some molten flux present. So as I said, I am making parallel diagram. We would be having some molten flux. Okay. And that molten flux would be provided at the welding area along with this electrode wire only. So my dear, let us say if this is the workpiece. If this is the workpiece, you know, we are going to make workpiece as positive, electrode as negative. So for that we would be having some power source, and my dear, for that we are going to have a connection like this. There is a power source which is going to connect both of these. This is going to be plus, this is going to be minus. and at the same time, my dear, you want that this wire and workpiece gap should remain constant. So to provide a constant difference, here we are using some servo mechanism. There are two rollers which are going to send the wire at a constant rate. So they will be sending the wire at a constant rate, and this is said to be servo mechanism. So my dear, we are using servo mechanism to work for the second thing. So my dear, if you see carefully what we are doing actually, one thing is we are using the wire for making it continuous. Second thing is we are providing servo mechanism to give a constant rate of wire so that the distance between both shall remain constant. So my dear, these are the two things we are doing. My dear, now we are using the molten flux, and this time molten flux means it is present in the form of liquid. So when molten flux will be coming, this wire will be producing the arc. This wire will be producing the arc. So that arc will be present in the pool of flux. So molten flux would be surrounding this spark. So because of that, this spark will not be going here or there. You can feel, if this is my welding area, if this wire is going to divert here or there, molten metal may spill over these surfaces. If molten metal is going to spill over these surfaces, this is said to be scattering of molten metal. This is said to be scattering of molten metal. And my dear, if scattering of molten metal happens, this will rise to a welding defect known as a spatter. So my dear, there are chances of a welding defect, spatter, to happen if this electrode wire is going to divert here or there. So to avoid that diversion, my dear, we are keeping this spark in the pool of flux. So you can see the spark will be produced, but that spark is going to be inside the pool of flux so that this spark shall not be diverted. So my dear, that is why surrounding it we are going to have the pool of flux, which will not allow this to divert here or there. So my dear, there are no chances of this defect spatter in this wonderful welding. So my dear, in this type of welding process, the first advantage is we are having continuity, so there is no leakage possible. The second advantage, you are providing servo mechanism. It becomes a semi-automatic type of welding, and in semi-automatic type of welding, my dear, you know that when the welding is of semi-automatic type, there are no chances of slag inclusion. Third thing, you are providing this molten flux which is surrounding it in this way, so it is not allowing the spark to spatter here or there. So it is not going to scatter the molten metal, so spatter will not happen. So a very sound quality of weld will be produced. Now my dear, from submerged, very good Divyansh, very good Bhanu. Bhanu, you are asking like coolant. No, coolant have no purpose here. Flux is not actually a coolant. Flux is going to just save the molten metal from atmospheric gases. Okay, from, you can say, oxidation it is going to save, because yesterday we discussed that metal can oxidize. So to save that from oxidation, we are doing all this. Then my dear, you can see in this process all the problems which we were having from the first welding process are being resolved. Are you agree at that point or not? Yes, in this we are not having slag inclusion. In this we are not having spatter. In this we have continuity, so we can definitely weld LPG cylinder shipbuilding using this process. So guys, agreed or not, please tell me that. Yes, agreed or not, please tell me that. Then we will move further. Yes guys, agreed or not on this point, then we will move further. Everybody, yes. So my dear, this welding process is a semi-automatic type of welding. So whatever the points we have discussed, we will see, and then I will be telling you one advantage also for this. Is it clear? So my dear, when we are talking about there is an advantage, what is an advantage? You know that when the welding process is going to be continuous. So if I am going to compare the welding speed Don't you feel that welding speed of this process will be better than the shielded metal arc welding process? Because here continuity is there. So definitely, my dear, we would be having a faster welding process. And if welding process will be faster, welding speed is going to be more. We know one more thing, my dear, that heat affected zone is going to be reduced. Because whenever we get high welding speed, the heat affected zone is going to be reduced, which was the weakest zone. And my dear, failure generally occurs for welded joint at weakest zone only. So we always want heat affected zone to be as less as possible. You might be thinking, sir, you have given so many points, how we will be getting these points? So my dear, handwritten notes of welding processes are already available on my Telegram channel. I have just shared it today, and there are two versions of that. One is the notes which, like whatever I am saying as it is written. Second is much explained notes also available. So if you want to follow any of those, you can go for it. These classes along with those notes will give you each and everything and complete idea. So whatever I am saying, everything is written as it is in the notes. Okay guys. Aram Kuti, actually right now we are online only, but we will soon be coming and then you will be getting informed. But online classes will give you the same feel, so don't worry about that. Okay. Yes, very good Shreya, Vishal, Divyansh, wonderful guys. So my dear, whatever the points we have discussed, let us see them. First of all, what are the application of shielded metal arc welding process? So my dear, the very first application is LPG cylinders. The second application is shipbuilding. So these are the application. Third is mass production. As you know, welding speeds are more, welding is continuous, we can go for mass production also. All these are application of submerged arc welding process. And my dear, then I will be talking about the advantages. So my dear, the very first advantage is it is continuous welding process. Second is it is a semi-automatic type of welding. Third is less chances of spatter. And my dear, this is one more information. Yesterday many students were asking that, sir, when we are going to have a session related to important topics, like in civil it is there, so when for mechanical it will be coming. So guys, the timing for this session is 10 p.m. The timing for this session is 10 p.m. on Thursday. Okay guys, so 10 p.m. on Thursday. Thursday means day after tomorrow. Okay, so me and Chandra sir would be telling you what are the important topics for GATE 2023 with which you can score very good marks. Okay, so this session will be at 10 p.m. on Thursday. Okay, do remember the timing. It is mechanical exclusive session. Okay. Divyansh, I have shared the full detailed notes in my Telegram channel. If you have not joined my Telegram channel link is Mechanical by Dheeraj Sardana. You can join the Telegram channel, there it is available. Is it clear? Fine. Yes. So guys, now let us see. We have seen the submerged arc welding. So my dear, submerged arc welding is all total a very good process. So my dear, when we are talking about submerged arc welding process, there are some limitations also. Because if there is no limitation, we will call it a best process. We need not to go for the third type of welding. Okay, so very good Bhanu Teja, wonderful dear. So what are the limitations of submerged arc welding process? My dear, the limitation when we are talking about, you know that flux is coming in melted format. So when molten flux is coming, so my dear, definitely if you are going to weld the thick plates, more will be the thickness, more will be the flux requirement. But my dear, if flux requirement will be more, it will definitely increase the cost of welding. So my dear, that is the reason for submerged arc welding we can go up to some 75 mm of thickness only. Not more than this thickness we can go. After that we will be using some other welding process. This is the first limitation. And when we are talking about the mass flow rate of the coolant, on that coolant you are saying, actually I was saying it molten flux. So that molten flux mass flow rate is also going to be a constraint. We cannot go with any rate. So if you would be having more thickness, we will be requiring more molten flux. So that is the second limitation. So second limitation is the molten flux flow rate. So these are the limitations. And my dear, the third limitation is submerged arc welding and manual metal arc welding both are unable to weld the materials like aluminium, magnesium and their alloys, because their weldability is very, very poor. So my dear, because of that, these two processes cannot weld aluminium, magnesium and their alloys. Rest all the problems were resolved by this process. So if you have thickness more than 75 mm, you cannot use submerged arc welding. If you are going to weld aluminium, magnesium or their alloys, you cannot go for it. So for those, we require some new type of process. So my dear, after manual metal arc welding, submerged arc welding came. After submerged arc welding, a third process came, and the name of that third process is Tig Mig type of welding. Guys, do like and share the session so that other student can also reach here. Now we are coming to this third type of process, that is TIG MIG process. First of all, I want to hear the name of these processes from you. What is the full form of TIG MIG? What is the full form of TIG MIG? Then we will move further, because that every student is aware of. What is TIG, what is MIG? I feel everybody would be getting something very, very new points related to the welding process which you have never seen before. Yes, what is the full form of TIG MIG? Madhuvamshi, Divyansh, Shreya, Vishal, Mondi Pavan, Aram. Very good, guys. Sudarshan, wonderful dear. So it is tungsten inert gas, and this is metal inert gas. So my dear, when we see the name, some of the students are getting confused here. When they see tungsten inert gas, when they see it metal inert gas, they feel it is a type of gas welding. But my dear, I would clear you one point, that they are TIG or MIG arc welding process. So they are TIG arc welding process. So they are not at all gas welding process, they are arc welding process. Because my dear, whenever you are taking the heat energy required for welding from the electric arc or spark, then this welding process is given the name of arc welding. And if you are talking about gas welding, there some chemical reactions are occurring and we are going to have some combustion reaction. Because of that we are getting energy. So if energy is coming from combustion, we will call it gas energy. If energy is coming from electric spark, we will call it arc energy. So we will call it arc welding. So TIG MIG are the types of arc welding only, they are not at all the types of gas welding. This is the first important point. So if you see, this is the setup of TIG welding. So as you can see, tungsten inert gas. So my dear, tungsten word is used because here we are using tungsten as electrode. So my dear, you can see there is a electrode of tungsten. As you know, I make wrong diagrams in the first attempt. So this diagram made is also incorrect. I will be doing it correct, don't worry. But for the timing, this is the tungsten electrode. First of all, the tungsten electrode is used. Tungsten is going to be a brittle material. And you know, we never want our weld bead to be brittle. So we never want that there should be any melting of tungsten and this tungsten would be going into our weld bead. We don't want that. We do not want that. So my dear, we do not want tungsten to melt out. So that's why we are making it as non-consumable. So my dear, this tungsten electrode is going to be non-consumable. When I am saying non-consumable, it is not going to be melted out. So when it is not going to melt out, who will provide the material for groove? You know, we need something to melt out and go inside the groove. So for that purpose, we are going to use some filler rod, and that filler rod and workpiece are made up of same material. They are made up of same material. So my dear, they are made up of same material, filler rod and workpiece. Okay, so my dear, initially we are going to provide the spark, and that spark is going to be produced between tungsten electrode and workpiece, and by taking energy from that spark, this filler rod is going to melt and provide the molten metal, and it will be getting inside the groove to make the weld between the two plates. Yes, it is correct. Yes, it is correct. Okay, then my dear, where is flux? Previously we were having flux as molten flux. Where is flux? So my dear, for flux we are going to provide some flux powder at the welding area, and some other thing that is nothing but the inert gas. Actually here inert gas is provided to save the area from the atmospheric gases, because you know inert gases are not going to do any reaction. So these inert gases will be surrounding the welding area, and they will not allow any kind of reaction to happen, because metal and oxygen, they will not be coming in direct contact. In between, inert gas would be there. And what are the inert gases we are using? You know that helium is an inert gas, neon, argon. Generally we are using argon. So argon is generally used as an inert gas for this purpose, and this inert gas will not allow any kind of reaction between metal and oxide, so there is no metal oxide formation. So this time inert gas is solving the purpose of flux coating, my dear. So are you getting? I know there is a lot of theory, but after this we have numerical. This is the last process for today. After that we have 5-6 numericals, and I feel in numericals you will be feeling better. Okay, so I know there is some theory, but we need to study theory also, guys, because in production without theory we cannot move ahead. But I am telling you all the theory points which are very important, as well as coming directly in exam. I am not telling you that theory where you will be getting bored. This is very interesting and important theory. Okay, yes. Nagaraju, actually I have not even told you right now why we are using this. Okay, let me tell that. So till now I said that we are using tungsten, which is non-consumable because it is brittle. I didn't tell why tungsten we are using, why not any other material. So I would like to tell you, my dear, there is a perfect reason behind using this tungsten. Tungsten is having very high melting point temperature. Tungsten is very strong also. So then you will be asking, sir, why we require that strong and that high melting point temperature, which was not required in previous two welding processes? So my dear, there is a very important point in that. What is that important point? My dear, that important point is, you have seen that we cannot weld aluminium, magnesium and other alloys of them using the previous two types of welding process. So what is the reason behind that? Actually, I told you yesterday that metals have a bad habit. When metals are in heated state, they are unable, when metals are in heated state, then they just see oxygen and they react with them and make metal oxide. Means they get excited at high temperature. But aluminium and magnesium are so much excited and reactive that they can do the same work at room temperature also. Aluminium and magnesium are going to make oxide even at room temperature. For that they need not to be heated. So whenever you see aluminium and magnesium at room temperature, what you will see? At room temperature you will see aluminium will be having an oxide layer already present. So you can see this oxide layer is already present. This oxide layer is Al2O3. So when this oxide layer is present over the surface, that is a brittle material, and Al2O3 cannot be welded. Okay, so if you want to weld it, you need to remove this layer. Until Al2O3 is present, we cannot weld it directly. So if you want to weld it, my dear, we need to remove this Al2O3. Yes, Madhuvamshi, that's why I said inert gas will be performing two functions. inert gas will be performing two functions. One is it will be keep it concentrated like this. Second thing, inert gas will be avoiding the contact of molten metal with the air. But my dear, for providing alloy content, you need to put some powder of flux if you really want to give some alloy content for such cases. But here we do not need alloy content. I am telling you about that. So just let me complete. You will be knowing the reason behind that. So as I already said, my dear, we are going to weld here with aluminium and magnesium. Aluminium and magnesium at room temperature will be having the layers of oxides, which cannot be welded. If you want to weld it, these layer needs to be removed. So my dear, what we are going to use for that purpose? Actually, till now we were making workpiece as anode, electrode as cathode. Here we are making workpiece as cathode and electrode as anode. So when we are making electrode, workpiece as cathode and electrode as anode, then what is going to happen? This is negative, this is positive. Do you remember electrons are going to go towards the anode? So my dear, I am showing it on to the next here, this slide. This is your workpiece and let us say this is your electrode. So my dear, this time electrode is positive, workpiece is negative. So you know, electrons will be traveling towards the electrode and positive ions will be traveling towards the workpiece. So this time 2/3 of energy is going to here and 1/3 of energy is coming to workpiece. So my dear, there are two advantages happening. First thing I would be telling you that when you are going to have this, then my dear, electrons will be going out from the workpiece. You know that because circuit is going to be there between these two. So my dear, because of that circuit, electrons will be going out from the workpiece. So when electrons are going out from the workpiece, my dear, while going out, they will be removing this oxide layer present over the surface. So they will be removing this layer, and by removing this layer, they will be going out from the surface, and this entire oxide layer is going to peel off from the surface. And my dear, this process is given the name of cathodic cleaning. This process is given the name of cathodic cleaning. Why? Because we have cleaned the workpiece surface by making it cathode. So that is why the process is named as cathodic cleaning. So by making this workpiece as cathode, we are making it clean. That's why the name is cathodic cleaning. And now fresh aluminium will be exposed for the welding process, and now welding will be getting produced. Because aluminium is weldable, it is good material, but Al2O3 is brittle material. So Al2O3 cannot be welded. So to remove this Al2O3, we have used reverse polarity. We have made workpiece as cathode, electrode as anode. So my dear, when you are using this, this is said to be reverse polarity. So in TIG welding, you are using reverse polarity. Because of that, now 1/3 energy will be coming here and 2/3 energy will be going here. So because of this 2/3 energy, my dear, to withstand this 2/3 energy, we wanted an electrode which can have that energy. So for that purpose, we are using tungsten because it is having high melting point temperature. But still, my dear, tungsten should be non-consumable. We cannot bear even a small droplet of tungsten into the weld bead, because my dear, even a small droplet of tungsten can make entire weld bead as poor and brittle. So to avoid that, we are not making the electrode of this shape. We are making the electrode of this shape. Just look at it. And this surface diameter we are keeping. If normal dia of electrode is D, we will be keeping actual diameter to be 1.2 to 1.5 times of dia. So we are keeping 20 to 50% more diameter, because we wanted that this surface must get more and more heat and its temperature shall rise by very small amount. So my dear, because of this we are going to take care that why we are using the tungsten to withstand more and more heat, and it should have more strength. So my dear, here only 1/3 part of energy is coming. For less amount of energy you can weld very thin plates. That's why the plates of 8 to 10 mm thickness of aluminium and magnesium only are getting welded by this process, and that is why we generally do not require any extra material to make you can say a weld bead and all, because the thickness of plate is very less, so more materials are not required actually. So that is why we are not much using about those things, because here we are joining very thin plates of 8 to 10 mm. So that is the point with TIG welding process. TIG welding process nowadays is not used in industries. It have been replaced. Like some students, Nagaraju is asking why we are using tungsten. As I said, when something is coming for the first time, they are just trying for something. So they tried for it. Then later on, they have removed TIG and they started using MIG. So before I start MIG, I would like to ask you, every point is clear to all of you about TIG or not? Please tell me that. So guys, I have tried explaining it in a wonderful manner. I know it is theoretical subject, guys. You cannot expect SFD, BMD, or you can say Mohr circle in welding. You cannot get that kind of things. But this thing is also very interesting if you try to learn with that point of view. So you can see shielded metal arc welding was the first welding process. We have seen the procedure. There were some shortcomings, like we were having discontinuity, we were having slag inclusions. So to remove that, we come up with the submerged arc welding process. If surface area high, getting deposition of tungsten is high. Dear, we are not allowing tungsten to deposit actually. If tungsten would be getting deposit, melted out, then there is a problem. So that's why we are making this surface to be bigger, and whatever this we have done, it is given the name of electrode preparation. It is said to be electrode preparation. So you must be aware of what is electrode preparation. So electrode preparation is providing more diameter of electrode to absorb more and more heat for less change of temperature. Okay guys, very good guys. So this is something very important we have seen about TIG welding. So my dear, after learning TIG welding, now we are coming to MIG welding. So when we have seen that we are using tungsten inert gas welding, inert gas was fine, tungsten was having a problem. So we replaced tungsten with a metal. Metal would be same as that of the workpiece. So then we come up with this as workpiece, this as workpiece. The same setup we are going to have. We are just replacing the tungsten electrode with the metal. And when you are using this metal wire, obviously there will be some wire spool. And for making the continuity, servo mechanism and power source will be there. So my dear, this is very much similar to the submerged arc welding. Only one thing is there. The work of flux is now done by the inert gas. The work of flux is now done by the inert gas. So here we will be providing the inert gas. Inert gas. And here my dear, this is metal electrode. As this is metal electrode, so my dear, it is consumable. It is consumable. So my dear, this electrode is a consumable electrode. This is not non-consumable. This is consumable only. So my dear, as this is consumable, there is no requirement of the filler rod. We do not want any kind of filler rod in this. But my dear, when we see this process, you are providing the inert gas for doing the function of flux. And my dear, in this type of process, you can use straight polarity also, reverse polarity also. Both the polarities are allowed. And when we are talking about this workpiece and electrode wire, once again the spark will be getting produced. Inert gas will be saving the spark to deviate. So my dear, you will be getting sound quality weld here also. So very good guys, you guys are learning in a wonderful manner. Then my dear, previously we have TIG in industry. TIG was replaced by MIG. But nowadays we have done one more smart work. What is that? My dear, inert gas is something very costly. So my dear, to reduce the cost, we have replaced this inert gas by CO2. Because CO2 is acting also like the similar inert gases, it is not allowing the reactions to happen. So this is the one more modification what we have done. But when you are using CO2, it is no more inert gas now. So maybe it is acting like inert gas, acting like shielding gas, but it is not inert gas. So the name of process will change now, and the new name is active gas metal arc welding process. Active gas metal arc welding process. This is how the name of process is being changed. So my dear, we can use this TIG, MIG for aluminium, magnesium and their alloys. But nowadays in industry, neither TIG is there nor MIG is there. We are majorly using active gas metal arc welding process. So this is nothing but MIG by replacing inert gas with CO2. Abdul Kalam ji, जो inert gases हैं, they are helium, neon, argon, because they are inert. Inert means they do not participate in the reactions. So that is why we are using them, because we wanted to save the molten weld pool from the air, because otherwise the molten weld pool metal can react with oxygen and make the metal oxides. Nagaraju, there are many things which are harmful, but we are doing. So they are not actually using at that much extent what you are thinking. Okay. Yes, Mondi Pawan, you can ask. So Nagaraju, you know that many rivers are going to feel very bad because we are putting the industrial waste into the rivers. That is still happening now. So for in industrial, as you can see, the industrial uses are coming or industries are going to grow. There are many things, many harm kind of things we are doing to the nature. But this is not using that much CO2 what you are expecting, and it is easily available. So we are not leaving the CO2 to atmosphere actually here majorly. Okay. So, and this is only for some specific applications. Okay. So we will see many more things related to that in the classes, don't worry. Okay. Okay guys, so now I feel the time is too much already. So guys, in this PPT, PDF I will be sharing with you, there are 8 more questions available. But today time is less, so we would be solving those questions in the tomorrow's session. Okay, so don't miss tomorrow's session, because we have solved only 2 questions. 8 more questions are there. Tomorrow we will see those 8 questions and we will start resistance welding process. And once you study resistance welding, major questions are coming from resistance and arc welding. After completion of 4 lectures, 80% of the previous year's questions would be covered. Okay guys. Yes, Bhanu Teja, very good. So let us say goodbye for this session, and we will be meeting tomorrow once again at the same time. And my dear, day after tomorrow we have already one more session for mechanical specific. So I have already explained about that, and on Sunday we have previous year's GATE questions of IIT Kanpur organization year, and where we will be having strength of material and engineering mechanics. So for both the branches, mechanical and civil. Goodbye guys for this session. Thanks for joining. Thanks for your love and support. So keep joining these sessions. They are really going to help you, and we want more students like Parvinder this year. Like yesterday, he was throughout the year dedicated. Be like him and follow the things he have done or other toppers have done, and be a topper. Yes. Mondi Pawan, I already told you that when we were using molten flux, there were some issues that we were having a limit over the flux, and cost was more at that time also. So as I said, when TIG was developed, the development of TIG was majorly for aluminium and magnesium alloys, where aluminium and magnesium's very thin plates we were joining with the help of TIG. Okay, so as I said, there were many other issues. So inert gases we were using to avoid the reaction, because aluminium and magnesium are very reactive metals. That is the problem. Okay, so goodbye guys, goodbye.